Okay, welcome to another epic coding session. This time I'm going to be coding this health checks integration for ZB workers, and this is just a proof of concept kind of idea. Not to be taken as something that you should necessarily do in production, but it'll give you some ideas about things that you can do. And I'm going to commit it into this repository here, the ZB Worker Health Checks POC repo on GitHub. Link in the notes. Okay, let's do this. Okay, so we're going to use VS Code. Here's my Twitter and my GitHub. You should be able to see those down the bottom. Okay, so let's get started. So first thing I'll do is npm init -y to create an npm. npm init, different keyboard from my normal one. That's why. Let's try that again. Okay, got my package. And it's going to be TypeScript. Cancel. So tsc double minus init. C double minus init. TypeScript project. Successfully created. Put the source into src. Why not? So we'll make a directory here called src. And then I'll just edit my tsconfig to say that it should build out a TOC. Base URL src and output directory dist. Okay, cool. So we're doing it in TypeScript. I'm going to install ZB Node. So basically the idea here is, how do we know when the worker is disconnected from the broker? So we can tell if the broker is down with some kind of health check on there. We can tell if the worker is down by putting some kind of health check in it. But what happens if the broker is up, the worker is up, but the worker cannot speak to the broker? Maybe the network went down. So here's one way you can do it. Gonna make it real simple. Okay, so we're going to import the ZB Node library. ZB client. Okay, and we'll make another directory in here called BPMN. So the way we're going to do it is we're going to use the ZB modeler to create a business process that runs in the broker and that just periodically sends a job to the workers, and then the workers have some logic in it so that they treat that as a special type of job. So what that looks like, if we go here, okay, create a new BPMN diagram, and then we'll put two tasks in here. We'll do it like this. You got the sound of Brisbane in the background. I'm out on my balcony today. So this one here will be task A. And we should use this kind of imperative language: do task A, do task B. Pretty simple. Type will be type task A, and this one will be type task B. So this is what our kind of normal process looks like. And then we're going to create a special health check process, and it's going to look like this. So we'll put a sub process in here. And inside here we're going to put a parallel gateway, and then we're going to connect two tasks to it. And we'll call it check task A, or check worker A. Now this is really only going to work if you have a single worker of each type. So you'll need a different solution, and then we'll join them back again. and we'll connect a timer to that. And then we'll loop from there to there. So it's just going to loop around, loop around, loop around. So let's call it a 5-minute health check. This is definitely not the enterprise solution, but you'll get some ideas from it. And then what we want to do is we want to put an interrupting boundary event on it. Because we want to be able to stop it. And create a new message, and we'll call it health check stop. And we'll correlate it on what we're going to call health check variable. So health check variable. Good. This one's going to be of type task A. This one's going to be of type task B. Now this is not particularly going to work if, for example, your worker's throw and cause an incident, because then your whole health check thing is going to stop. So there's another solution that I'll show you later in another coding session where I'm going to code it into the library. Okay, so looks pretty good. Health check ID. Call it health check pulse timer. Okay, so we're going to save that into workspace, Commander ZB, worker health checks POC, BPM in. I'll give it the same name as the process ID. Health check dot timer. Okay, let's go back to VS Code. So we'll create a main function here. That will be our bootstrap. Async function main. So create a new ZB client. Now if we don't put anything in the constructor, it'll just run against either a local host, so that's localhost by default, helicopter, or it'll pull the ZB gateway out of the environment. Anyway, first thing we're going to do is we're going to await the deploy of that thing, so we're going to say deploy workflow. Where ZB deploy workflow. BPMN health check dot timer. BPMN. Okay, so it deploys it, and then the next thing we want to do is we want to publish a message. And so we'll make a constant here, which is health check var equals, we'll call it io underscore zv. Health check. So we're going to publish a message. Message name is health check stop, and variables correlation key. Which should be correlation value, but whatever. Like that. And I think variables is what am I missing? Time to live. Just immediate. Okay, so await that. Publishes that message. And then the next thing that we do is we start a new instance. So this will cancel any running health checks, and then we're going to start a new one. So create a workflow instance. And it's health check timer. Create, not cancel. And then we're going to give it some variables. So we're going to say, let's have a look at the correlation key. Health check colon variable. So actually we'll give it, make it an underscore. So now what we do is we make the health check underscore variable. And actually what we could do is this, makes it a bit easier. Rename that symbol to this. And then we can just blow that away. Okay, await the start of that. And then, yeah, so we'll create two workers. So the first worker is for task type task A. It's going to take a job and a complete function. And create this second one. So let's copy the first one. Three to five arguments. Takes an ID. Yeah, that was a bad choice of signatures. Should have made it an object. Because now I can't make the first one optional, but I just made it take a null. Okay, so the first thing we do here is we just go const, get the variables out of the job. And then we do this, we say if variables, and then if the health check variable is there, then what we do is we just go complete success. Oh no, what we need to do is we need to ping some kind of health endpoint. So both these handlers are the same, and then what happens here is we should return from that because we don't want to execute the normal logic in the worker. Okay, so the actual task A logic goes here. Task B logic goes here, and then just complete success. Okay, so what we can use healthchecks.io. So if I install the healthchecks.io package, and here's what healthchecks.io looks like. Dolphins. Healthchecks.io, so you can get an endpoint here that you can ping. So I can copy that. If we have a look at integrations, you know, it'll send me an email if it goes down. And then you can have Slack, email, webhooks, Discord, Matrix, Mattermost, tons of stuff. Pages, pushover, SMS, Telegram, Trello, WhatsApp. Add some more. But you can have a webhook, so you can do basically anything. So let's go back to the checks. Well, let's create two of them, right? New check is ready to go. Let's give it a name. So we'll call this one worker A. And we'll change the schedule. So our timer we set for 5 minutes, and I just remembered I got to set that, so we'll set this for every 5 minutes, and we'll give it a grace time of like 2 minutes, 3. Save. Okay, now if I go back to the modeler, I actually need to set the time on there. ZB modeler. Here. Timer duration, PT 5 minutes. Save that. Okay, go back to Chrome for a second. And then I'm going to copy my health check. Copy URL. Then I go back to VS Code. So I'll import my health check. Actually, no. The health check actually works on a timer by itself, so that's not going to be the right thing to use. So we'll remove the health checks. That would be useful for making sure that the worker is alive, but we want to make sure that the connection is alive, so I'm just going to install Axios. We should be able to get an auto import here, so in here we'll say Axios. Nope. Okay. Import. Let's see what we can get from Axios. What does it offer? Okay. Well, star as Axios. Lowercase. So here we're just going to say axios.get, and here's my worker 1 health check endpoint. Doesn't have a get on it. What has it got? Default. Okay, like that. So there we go. I just get the Axios endpoint. Now I'm going to wrap that in a try catch because it's not async. So it could throw, but the complete it'll happen asynchronously. So it's going to go off and try to get this endpoint. So if you can imagine that the couple of things could happen. One is that the worker loses its connection to the broker, so this task handler never gets called by the health check timer, or the worker loses its connection to health checks, so it can't ping the health check endpoint, in which case health checks will alert you that the worker is not alive, because this will only be triggered by a connection with the broker and the broker sending the jobs. So then the other thing you could do is you could use health checks to make sure that the worker is alive. Just put it in here, and then that would give you information about whether the worker was dead or whether the connection was down. But if the health checks connection goes down, well, then you won't be able to tell what's happening. So that's basically it. So you have like a little bit of logic at the beginning of your worker here, that when it gets a specific type of task, if you like, it's going to call the endpoint. I mean, another way you could do it is you could put a custom header on that task rather than using this variable, but you do need to use the variable to be able to target the running workflow and shut it down with this message here. Otherwise, every time you start your application, it's going to create a new instance of that health check timer, and then you're going to have multiple of them running, which is not ideal, obviously. So you want to shut down any running ones and then start a new one. So it's like a singleton process that runs in your broker, and it kind of exercises your workers as they run. So I'll write a little bit of documentation for this. Okay, I guess I'd take a photo of the modeler, hey, and add it in there. That'd be cool. So I'll go to the modeler, take a screenshot. Okay, so create another one called images for the README. And then I want to drag it in from desktop. That's where it went. This one. Let me take you back to VS Code. Here we go. Let's change this to bpmn.png. Okay, README. Here we go. So it proves that at least one worker per task type. So you can instrument the broker at an infrastructure level. Okay, I'm going to have to concentrate on typing. Colmac keyboard. Infrastructure level to alert you when it is down. You can also instrument workers to alert when they are down. The workers to alert you. So you can use this with any language client when they have no communication with the broker. Okay, one idea is to run a timer process on the broker that like heartbeat pings. So the heartbeat task could either be No. Should be on the same task type as the business logic task. And I'll make a note in the node client at least. Each worker has a single task type and a dedicated gRPC channel. It's got a dedicated gRPC channel. So let's go back to the modeler. So we're going to modeler. Nope. Yes. So we'll grab this first one here. Screenshot that little puppy. We'll go back here. VS Code. Here's what it could look like. Most work around open source is documentation, education, examples, issues. So image / business process .png. So given this business process, with two tasks in it. I'll type task A and task B. Create a health check time heartbeat, I'll call it. Heartbeat process like this. This is a good track. So I'll just copy that. Wow. Is it the right one? No. Yeah, it's in the wrong place, that's why. This one. Okay, so this is just called BPM in. Okay. So it has an infinite loop. So it runs continuously. Okay, the interrupting boundary event. So you can ensure that multiple instances are not started. In your application, you simply publish the stop message, which will cancel all running instances. And it cancels all running instances because you always have the same correlation value set for that variable. Publish the stop message and create a new instance. Okay, in your job workers. They're called job workers because a job is a specific instance of a task. You put some logic at the start of the handler to ping a health check endpoint. Has the heartbeat variable set. Yeah, okay, so the other thing that we should do here is, because this message correlation is a little bit tricky, so we're going to put a link to the message correlation from the ZB blog. I did a pretty cool article in there about it, specifically just kind of stepping you through it. Here we go. ZB message correlation. Dun dun dun. See this blog article. Message correlation in ZB. You could use healthchecks.io, as I have in this example. Okay, I'm going to go back into my code and change it, because just as I write that, I'm thinking of someone reading it and going, how does this all fit together? And I got a magic string in there. No magic strings, and the magic string is this. So what I need to do is, let's see if I can do this. Refactor, extract to constant in function main in module scope. Boom, and we're going to call it task A health check URL. With a capital T. There we go. There it is. And you do the same thing in here, but that may not be clear to someone. So just copy that. Modify it here. C734. Call it task B, and then if I go down here and actually the other thing that I can do is this. Refactor. Can I refactor it like this? Extract to function to constant. Let's try that. Cool. So is health check heartbeat. Good. And then this becomes the task B, health check URL. Okay, make this a link to healthchecks.io. Meal ready to eat. HTTPS healthchecks.io. .io. Or your own infrastructure. Okay, some features, limitations. I'll call it limitations. Some limitations of this approach. Okay, This approach can alert you there are 0 workers for a given task type that ping the health check endpoint. It cannot make a statement about the number of workers running for a given task type. Now, if the worker cannot fetch the health check endpoint, you will be alerted that no worker is running for that task type. However, it may be but unable to reach the health check endpoint. That's another thing. What else is there? There's another aspect of this one. If the broker goes down, they're not going to ping. If the worker goes down, they're not going to ping. If the broker is running and the worker is running, okay, so we'll say if you have separate separate heartbeat health checks in your workers, that makes a statement about whether they're running. If you get so no alert for the worker down and an alert for this heartbeat going down, means the worker is up. But not getting tasks from the broker. The broker is up, well, the broker is down, which includes, well, the heartbeat process has been stopped, or the communication between the worker and the broker is down. So we'll put this one in a note. So when designing a system with ZB, you need to look at the different things that can go wrong and figure out how you will detect them and alert on them. So I'll do another screencast where I'm going to modify the client library to put like a on disconnect, so when it loses its gRPC connection, you can put like a tolerance, so if it like loses it for 5 minutes, it can call a callback handler, and that's when you could ping some kind of point or stop pinging a point. It's another way you could do it. Okay, yeah, I think that should be good. Do I need to comment the code? Let's have a look. Yeah, I do. Okay, so here, halt all running instances of the heartbeat. Create a single instance of the heartbeat. Well, let's call it the health check timer, just to keep it consistent. Naming things. Process. Copy paste. C. Control V. Man, my typing speed used to be way faster than this. Hundreds of words per minute. But I switched to Dvorak for a year, and I've been on Colmac for like 2 or 3 months. Okay, so now, so we can say start health check logic. End health check logic. See, same thing here. Start, end. Okay, looks good to me. Well, let's just have a look at it here. Okay, an idea about proving that at least one worker, an idea about how to prove that at least one worker is running for each, one worker per task type has a connection to the broker. Yeah, that's it. You can instrument the broker at an infrastructure level to alert you when it's down. You can also instrument workers to alert when they are down. However, can you instrument the workers to alert you when they have no communication with the broker? One idea is to run a timer process on the broker that heartbeat pings on each task type and a worker type, and a worker has to ping a health check endpoint when it gets the special heartbeat task. The heartbeat task should be on the same task type as the should have the same task type as the business logic task. In the node client, at least each worker has a single task type and a dedicated gRPC channel. Here is what it could look like given this business process with 2 tasks, of task A, type task A and type B. You create a health check heartbeat process like this. It is an infinite loop, so it runs continuously. The interrupting boundary event is so you can ensure that multiple instances are not started. In your application code, you simply publish the stop message. You publish, the stop message, which will cancel running instances and create a new instance. See this blog article about message correlation in ZB. In your job workers, you put some logic at the start of the handler to ping a health check endpoint if the job has the heartbeat variable set. You could use healthchecks.io as I have in this example with your own infrastructure. Some limitations of this approach. This approach will alert you when there are 0 workers for a given task type that ping the health check endpoint. It cannot make a statement about the number of workers running for a given task type. Other than that, it is non-zero. It's not going to be negative. If the worker cannot fetch the health check endpoint, you will be alerted that no worker is running for that task type. However, it may be running but unable to reach the health check endpoint. Note, if you have, so this is the difficult thing here, is the health check endpoint. We'll call it the health check monitor endpoint. It would have been good maybe if I called it heartbeat rather than health check, because healthchecks.io is like one piece and the other one is a heartbeat. So it'd be heartbeat timer, yeah, heartbeat stop, heartbeat variable, heartbeat timer, heartbeat variable is heartbeat. Oh, that makes a lot better, because then you got this health check thing. Heartbeat variable. Naming things. Okay. Rename the symbol. Let's do it. So we're going to call it a heartbeat. Yep, okay, so we'll call this heartbeat. Heartbeat timer. Change this to heartbeat stop. What's happened to my music? Did we run to the end of the playlist? Let's try this. Okay. Back to VS Code. Heartbeat stop, heartbeat variable, looks good. Heartbeat is heartbeat. Rename symbol is heartbeat. Yes. Rename symbol is heartbeat. Refactoring from memory. Looks pretty good. Save that. Okay. I'm going to have to go back to the ZV modeler. Yep. And, okay, we're going to change this to heartbeat timer. Heartbeat, name, heartbeat. And task A, task B, 5-minute heartbeat. Yep, stop heartbeat. And then the process name, heartbeat timer, heartbeat, looks good. Save it here. Conroe. So go back to VS Code. This is where I'm going to rename the file here. Heartbeat timer. Boom. Okay, I haven't even run the code. Heartbeat timer BPM in. Looks good. Okay, so we'll just go back and modify this to make the distinction clear. Instrument, health check, instrument alert, a heartbeat timer process. That heartbeat pings. Yep. And a work has to ping it. Okay, so then, see, it makes it clear. Heartbeat, and then it pings the health check. The heartbeat task. Yeah. It's good. You create a heartbeat process like this. Good. Dun dun dun. Logic the starter handler to ping a health check. Yeah, heartbeat variable. Yeah, it started to become clear to me as I was writing it actually. You could use healthchecks.io. 0 workers that ping the health check. Yeah. The heartbeat process. Okay, so it actually started to become clear when I was describing it. Let's have a look. Health check, heartbeat. Yep, heartbeat, 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 heartbeat. Health check variable. Correlation key. Okay. Open heartbeat timer. Yeah, the correlation on here. Heartbeat stop. And this needs to be heartbeat variable. Okay, I think I've got everything now. You know, better than doing this would be to make it a custom header. No, easier not to. Just leave it like that. Okay, let's push it. Looks good to me. Push to prod. I'm using this approach in my own system that I've got running. I've got like a test development system where I try these kind of ideas out, run into problems, figure out how I fix them for myself, and share that kind of stuff. So there's another couple of problems. The guys in Come On to Cloud asked me about the HTTP worker for a connection test for that, and then the Node-RED guys also asked me for Node-RED, so I'm going to implement that in the library, another approach, but we'll do that in another session. Okay. There you have it. On Twitter I'm @CedarPutty, on GitHub @JWolf. Rock on.